Hello everyone, this is another video from Easy Electric series, and today we want to design a 4-bit synchronous up counter. So as that's clear from the name, you want to have one up counter that's 4-bit. So as you could see here, start to count from the 0, 1, 2 and end up with 15. Whenever it's count 15, again it should be back to the 0. So that's actually the synchronous. So that means if you use 4 flip-flop, the all clock pulse in these 4 flip-flop, they should be actually connected to each other. So let's see how we could design that. So this is our design. So we use 4 T flip-flop. So they are actually rising age T flip-flop. So the first T flip-flop is connected to the 1 and the other input of these T flip-flop connected to the clock pulse. So this is actually produce the Q0, which should be matched with this column that we have here. So if this is 1, you already know about the T flip-flop. Whenever input is 1, it's just toggle whenever it sees any actually rising age clock pulse. So you have the initialize circuit, which is connected to the all clear pins. Whenever you active that, so you actually load 40 here. So that means you start from this case. Then I'm just consider the first flip-flop. You have the input 1, so that means whenever it sees the rising edge, it just toggle. So I start with the 0, so then in the next rising edge should be toggle, so you will get 1. In the next actually toggle will be 0. Next toggle that 1. So next toggle will be 0. That means so these actually first flip able to actually make these column Q0 that we have. So next actually the second T flip-flop, actually the T input connected to the Q0 and the clock again connected to our main clock pulse input, and that will be produce your Q1. So let's see and check if it's actually able to make this column that we have. So if you check the Q1 column, so you start from the 0 at 0, so then the Q0 actually is the input for the second T flip-flop. So that means whenever it is 0, so the input is 0, so definitely it will be hold. So here it's actually toggle from 0 to 1. So that's happened whenever your Q0 is 1. So that means here the Q0 is 1, this input. So that means the input of this T flip-flop is 1. So whenever the rising age happen, it's just toggle. So that's actually, you see here it's toggle from 0 to 1 whenever Q0 is 1, right? So if you check that the whole actually should be happen in the same way. So here you have a 1 to 1. So here the Q1 is actually toggle. So that's actually when this Q0 is 1, right? So that's move from this Q1, move from 0 to 1 to 0. So again, the next here you have toggle, it's 0 to, again the Q0 is 1. So if you check, whenever the Q0 is 1, the Q1 actually toggle from 1 to 0. So see, here is 1, it's actually toggle. So here is 1, it's toggle. So here it's Q0 is 1, so it's actually toggle. So that means, yes, if you connect the Q0 for the second T flip-flop, this Q1 definitely produce the second column, which we label that as Q1. So let's check the third one, which we actually put as an output Q2, and see is it able to produce these third column that we have. So the input of this third T flip-flop is the Q1 and Q0 AND, right? So technically, because I don't want to get very busy drawing, so for that reason we actually put 2 Q0, but technically it should be connected to this Q0. We just label that here Q0 because we want to actually get more clean drawing. So let's see how it's able to produce if you AND Q0 and Q1 and connect to the third T flip-flop, and it should be able to make Q2. So again, you start to active initial pins, so it's load 0, so that means Q2 is 0. So then if you check the end of Q0 and 0 and Q0 and Q1, here is 0, here is 0, here is 0. So that means it should be hold. So that's the reason you have 0, here hold is 0, hold is 0, hold is 0. So whenever it's need to toggle, you just check the end Q0 and Q1. See, whenever it's moved from 0 to 1, so that means this Q2 actually move from 0 to 1, which is happen here, move from 0 to 1. So see here Q0, Q2 actually toggle from 0 to 1. That's the time is just and Q1 with actually Q0 is 1. So that means it should be right if you connect the end of Q0 and to 1 to the third one. So see here is 1 and 1 and Q0 and Q1 is 1, so toggle happen, right? So then again all of them is on the hold. Here it's toggle happen, but if you check Q0 and Q1 you see there and is 1. So that means this input is 1. Whenever the clock rising age happen, it should be toggle, right? So the same thing for again here toggle happen. If you check and the Q0 Q1, it's actually the only case it is actually 1. So in the other cases they are not 1 and it will be hold. So the same story for the last one. If you check the last T flip-flop which is produced Q3, you just check the Q3 and see the input of this last T flip-flop is Q0 and Q1 and Q2. So that means whenever all these three is 1, you have 1 here and then it will be toggle. So here you active this initial circuit, you got the 0, but here there and is not 1, should be hold. Here and is not 1 is will be hold. So see, the only case that the all of 3 is 1 is this case, which is and is 1, so that means that will be toggle. So see here toggle happen, it's moved from 0 to 1, okay? In the other cases, there is no toggle. The only toggle happen whenever all these three is 1. So that's the reason you actually add these three Q0, Q1, and Q2 and give that as an input. So similar with the other counters that we design for up counter. So for up counter, the preset pins all should be actually inactive with 1. And the clear pins connect to each other and we label that as initial circuits or input. Whenever you want to start to actually your up counter, you need to just active that it's load for 0, then start to counting the rising age of your clock pulse. So here I have the simulation. So here you see that's exactly the same circuit, the all clock pulse actually connected to each other, and here we connected to one function generator to generate the clock pulse. Here we use the actually the falling age, but it should be the rising age. We just use not the clock pulse, so that means it convert these flip-flops from falling age to the rising age. So that's what you have here. So also I use here the falling age flip-flop, but because I use the not in the in the pass of the clock pulse, it actually means these 4 actually is falling age. So I use the JK, connected J pins to the K, so which is the same with the T flip-flop, right? T flip-flop is the JK flip-flop, which is J connected to the K. So that means this is exactly the same circuit that you have here in your design. So here this is our initial circuits. So and we have 4 inputs, output to Q0, 1, 2, 3. So if you want to see how it's work, first you need to simulate this here. I active the initial. Whenever that's active, it's load for 0. Then it's back here. It's start to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is actually 13, 14, and 15, and again back to the 0 and 1, 2, and continue to counting. So I have another simulation here, so which is exactly the previous circuit. The only difference is I don't want to see just a binary number. I use one binary to 7 segment or binary to decimal code converter. So we actually talk about how you could design the binary to 7 segment or decimal code converter. If you check our previous videos, you could actually find that this is exactly our previous design. The only difference is I connected this Q0, 1, 2, 3 to the binary to 7 segment code converter, and I'm able to see that binary number into 7 segment. So same story, let's just back to here. I just stop this simulation. Back here I simulate this. So again I start to active initial. So if you active that, it's low to 0 that you see. Then actually back here start to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, and again it's back to the 0. So I hope you actually like this video. Don't forget to subscribe the channel and support us to upload more videos. Thank you for watching.